Okay, again, we're now in 10.4, and this section talks about ANOVA, which is an abbreviation of a one-way analysis variance to test the claim involving 3 or more means. This particular type of hypothesis testing requires you to state that in the middle, all the population means are equivalent, and the alternative, at least one, is different. Each sample must be randomly selected from a normal or approximately normal population, independent of each other, and each population must have the same variance. Some of this stuff might be unrealistic, definitely above our pay grade, so to speak. So we are not going to try to calculate one-way ANOVA on our own. I would like to just point out to you how to use it in StatCrunch. So, one of these days I'll find what I'm looking for. So here's an example of, well, let's go back to the prompt. Here's an example of a medical researcher that wants to know whether there is a difference in the mean length of time it takes for 3 different types of pain medicine to relieve your headache. And so in the following information, we're given that the medications for medication 1, 2, and 3, these are the different times it took to relieve your headache. So if you'll notice, our sample means do differ, but the question is, do they differ enough to matter? So I'm going to go into StatCrunch and put all of the stuff that's in this table into StatCrunch. So I'm going to pause my video, maybe you can do the same, and enter these 3 columns into StatCrunch. Okay, now that I have all this data in a table, I come into Stat, and I choose ANOVA, and it's a one-way ANOVA, that's all we'll do. And we need to select the columns, and who do we want to compare? We want to compare all of these. And so I clicked them all. And then I should just be able to tell it, compute. So I'm going to ignore all this other stuff that it's saying to me, because I'm not going to lie to you, it's been a long time since I've done any of it myself. So I click compute, and sure enough, I get everything I need. This has an F statistic and a large p-value. So what would you do with a p-value that size? You would fail to reject your null. What was your null? That they were all the same. So what is your conclusion? That they are all the same, even though they were different. So it'll calculate the means for each of the columns, find standard deviation, but what we need to pay attention to, as always, is what is the p-value. Now, I'm not trying to give you all of this to confuse you, and I'm certainly not trying to avoid having a conversation about real math. I just wanted to show you that with a little bit of knowledge, you can get yourself in a lot of trouble. Okay, so do we need one more? Let's look at the slides. So we go back into the slides. And so our hypothesis was that all 3 were the same, and the alternative is at least one is different. And in this particular case, we found that our test statistic created such a large p-value that we did not reject our null. So the slides also show you how to do it on the TI, for those of you interested in doing that. And we are not covering two-way ANOVA. Okay, thanks for listening.